In this video, I'm going to look at integrating inverse trig functions and inverse hyperbolic functions. We're going to use a little trick that you have already met. If we first look at the integral of log x dx, then if we introduce a 1, it makes no difference, and we can start thinking of integrating by parts. Let's take u equal to log x. U dashed is 1 over x. V dashed is 1. V is x. And so this becomes uv, which is x log x, minus the integral of v, which is x, du by dx, which is 1 over x dx. X times 1 over x is 1. Integrate it, we get x log x minus x plus c. This little technique is really very useful when you're trying to integrate something which you can differentiate, but you don't know the antiderivative. So let's see what happens if we apply that to something like arc tan x. Integral arc tan x dx. We can differentiate arc tan x. It's 1 over 1 plus x squared. But at the moment, we don't know its integral. So let's multiply by 1. And then we put u equal to arc tan x. And therefore, u dashed is 1 over 1 plus x squared. V dashed equals 1. V is equal to x. And so my integral is uv, which is x arc tan x, minus the integral of v, which is x. Du by dx is 1 over 1 plus x squared dx. X arc tan x. Now, if we look at this, it's 1 over u du by dx if we ignore the numbers. So that suggests that it comes from log u. If I differentiate log 1 plus x squared, I get 1 over 1 plus x squared times 2x. I get 2 times what I want, so I need a half, plus c. So there's a very simple little trick which will work with all the inverse trig, all the inverse hyperbolic ones. Let's just see it happening with r cosh. Integral r cosh x dx. Once again, we know how to differentiate r cosh. It's 1 over root x squared minus 1. So if we multiply by 1, we can now say, let's put u equal to r cosh x. U dashed then is 1 over root x squared minus 1. V dashed is 1. V is x. And you can see when we do this, when we get to the v du by dx term, all the awkward bit, the r cosh part of it, has disappeared. So this is equal to uv, which is x r cosh x, minus the integral of v. Du is root x squared minus 1 dx. This looks like u to the minus half times du by dx, if we forget the numbers. So we should look at differentiating x squared minus 1 to the half to find out what's happening. Half x squared minus 1 to the minus a half times 2x. So it's exactly equal to the integrand. This tells us now, therefore, that we've got x r cosh x minus root x squared minus 1 plus c. Simple little trick, works nicely because, as I said, by the time you get to here, all the hyperbolic side of life has disappeared, or if you're using an inverse trig function, all the trig side of life has disappeared.